So here's another problem. So we have a river flowing due east at 3 miles per hour. So a boat is crossing the river diagonally with its prow pointed in the direction of south west 30 degrees. So in still water, the boat moves at 10 miles per hour. So what is the true velocity of the boat? So let's first start off by looking at the boat. So we're going to draw our navigation system. And we know that this boat is going southwest with a bearing of 30 degrees. Okay, so we know that this boat is going at 10 miles per hour if there is no if there's no flow, so in still water, so nothing's going on. But we know that that's not the case. We actually have this river that's going due east, so it's going this way in this direction because east goes this way. And this is going at 3 miles per hour. Okay, so we have our so it's kind of very similar to the other problem. It's just that now we have a river. Now here what we want to be able to do is let's first start off by finding the components of the boat and of the wind. I'm sorry, and of the river. So let's look at river. So with the river, notice that it's going in this direction. So if we were to try to find the components, it's going to be 3 times the cosine in that direction. Well, this direction is just 0. Okay, comma 3, and then the sine of 0. So this is going to give me 3 and then comma 0. So this is going to be the vector form of the river. So now what we want to do is we want to find the vector form of the boat. So I'm going to write boat. So the vector form is going to be, so notice that this is going 10 miles per hour times the cosine of now the degree. So now you have to be very careful because now that 30 degrees is not what we want. We want this particular degree. So first of all, the first thing that we can do is figure out what this guy is. Well, if this is 30 degrees, the other guy should be 90 degrees. Oh, no, that's wrong. This should be 60 degrees. So this is 60 degrees. Okay, and I know that this whole thing is 180. So I'm just going to take 180, okay, and then I'm going to add this 60 degrees, which is going to be 240. So this is going to be the cosine of 240, comma 10 times the sine of 240. Okay, so now what we're going to do, we're going to take 10. We're going to take the cosine of 240 degrees. That's going to give me -5. And then we're going to take 10 and we're going to take the sine of 240 degrees. That's going to give me -5 square root of 3. Okay, and this makes sense. If you have used 30, if you would have used 30, then you would have been in quadrant 1. So you had to use a little bit of geometry to figure out that that's going to be 240 degrees. So now the true velocity vector, so the velocity vector is going to be the addition of these two vectors. So it's going to be 3 comma 0 plus -5 comma -5 square root of 3. So this and this is just going to give me a -2. And then this and this is just going to give me -5 square root of 3. Okay, so now all we have to do, because we don't want the direction, we just want the true velocity of the boat. So all we got to do is just take, figure out what the actual thing is by taking the magnitude. So we're going to take the square root of -2 squared plus -5 square root of 3 squared. So let's put that in our calculator. So you're going to have -2 squared and then plus -5 square root of 3 and then the whole quantity squared. And what I end up getting is the square root of 79, which is approximately equal to 8.9. And in this case, it's miles per hour. Okay, so actually the speed of the boat is a little slower now going in that direction. Okay, which actually makes sense because if you're going this way, then you're impacted. So there might be a little bit more work that you have to do.